Here we have a hemisphere, and a hemisphere is just half a sphere. Now, if you look at the formulae in the front here, in the front of your exam paper, basically it tells you that if you have a sphere which has a radius, okay, the surface area, that's the total surface area, will be 4 pi r squared. So that's the area of the whole of the outside. Imagine that's like the skin of a football or something. Okay, so here we have a hemisphere. Now the problem here is in two parts. First of all, we have to find the curved surface area, so that's the bowl-shaped piece on top here. Then we have to add on the area of this circle on the bottom. Okay, so let's get started. So basically the curved area, so the curved surface area, well, that's going to be half the surface area of a whole sphere. And if the surface area of a whole sphere is 4 pi r squared, then for the hemisphere, the curved surface area is going to be half of that, which is just 2 pi r squared. In other words, we're going to do 2 times pi times 2.8 squared. And if we work that out, that comes out as 49.260 blah, 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 blah. Now what I'm going to do, I'm probably just going to save that in the memory of my calculator. I'm just going to call it A. Okay, what we now need to find is the area of the circle on the bottom. Okay, so the circle on the bottom, now it is just a plain old circle, and its area is going to be pi r squared. In other words, it's going to be pi times 2.8 squared, which comes out as 24.630. I could save that in my calculator memory as well. In other words, the total surface area is going to be those two added together, so 49.2 blah 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 plus 24.6, and if we add those together on the calculator, it gives us 73.8902, which I'm just going to leave on my screen. If I round that to three significant figures, that's 73.9 centimeters squared. You could also have noticed that what you're doing is you're adding 2 pi r squared to 1 pi r squared. In other words, a quicker way would be to work out the total surface area by doing 2 pi r squared plus pi r squared, which is just 3 pi r squared. Okay, so you could have just done 3 times pi times your radius squared, which is your 2.8 squared, which again gives you your 73.89, and so on. Okay, right, the second part of this question is talking about volumes. Okay, now what this means, if we have one hemisphere, so we've got a little hemisphere, okay, which is our hemisphere A, and we've got another bigger hemisphere, and it tells you that the volume of that one, okay, which I call the volume scale factor, the volume of this one is 125 times the volume of this one. That means that the volume scale factor is 125. So this volume is multiplied by 125 to find this one. Now, what you should know is that if you have a length scale factor, then that will be cubed to give you the volume scale factor. So what we need to do is figure out what the length scale factor is. So what number cubed gives you 125? Well, that's asking us to find the cube root of 125, which you can find on your calculator, and it comes out as 5. That means, for example, the radius of this one is multiplied by 5 to give us the radius of this one, or the height of the larger one is 5 times the height of this one. To find the area scale factor, because the question is asking us about the surface area of the larger one, the area scale factor is just the square of the length scale factor. In other words, it's 5 squared, which is 25. So in other words, areas are multiplied by 25. Now we've just worked out in part A here that the surface area of this one, which is A, was the 73.89. So if we want to work out the surface area of this one, it's going to be that 73.89 multiplied by 25, because the surface area of this one is going to be 25 times the surface area of this one. And if you work out the 73.89 multiplied by 25, we get 1,847.256. This is our calculator answer. Now we've got to round it to three significant figures, so I'm going to chop off after the 184. That 4 is going to have to round up to 5, so it's going to be 185, but I have to slot in that 0 to keep the number approximately the right size, which means the total surface area of the larger hemisphere, hemisphere B, is going to be 1,850 centimeters squared.